Thanks. Yeah, so I'm Trond Løke. I'm the CEO of NEO. That's short for Norwegian Elektro Optikk. So we are, amongst other things, designing and producing the hyperspectral imaging systems called HySpecs. Just start with a quick intro of NEO and HySpecs before I will talk about our stratospheric and space activities. And in the end, just a short reminder about data quality. We are almost 40 years old now, spin-off from the Norwegian Defense Research Establishment. We are doing everything in the world of photonics, I would say. We are a research-heavy company, but we always do our research with a goal to develop kind of commercial products. One of those commercial products are HySpecs in the hyperspectral imaging market. We have headquarters in Oslo, a sales office in the US, and a subsidiary software company in Sweden. In Oslo, we have 60 employees, half in R&D, and we are growing fast, as I said, and our owner is a non-profit foundation with a vision of supporting both art and physics. So it's a nice owner to have. We are doing, as I said, we are research heavy, and we are doing a lot of projects, EU and international R&D projects. We have done that since 39 years ago now. One good positive thing about, I would say, collaborating with us is that we have all the resources internally to design, develop, and produce all our electro-optical products. Also sell them. All systems that we make today, hyperspectral solutions, are push-broom systems, except one actually that we are starting very soon with somebody here also, or some other participants here. But we have focused on the push broom because at that architecture you are capturing a narrow line on the scene and all the spectral information at the same time, meaning that, that has the kind of the architecture with the highest spectral fidelity per pixel. We are offering kind of multi-scale offerings all the way from laboratory, field to drone, airborne, stratospheric, and satellite. We flew our first system 21 years ago. We flew our first UAV system in 2012. We flew our first stratospheric system in 2022, and we will fly our first satellite mission next year. So now I will focus on what we do in the stratosphere and on satellite activities. We delivered our first stratospheric solution to USGS in 2022. It was a customized version of a Mjolnir V1240, a visible near-infrared solution from 400 to 1000 nanometer. It was especially made for this Swift hail drone with a 3.5 kilo solution adapted for the nose here. But we flew it in 2022 on the NASA ER2 platform. Of course, it's a huge one relative to this one, so we had a lot of space. And today you can get all our drone and classical system as a kind of stratospheric solutions. There is some adaptation to focus where you focus the system and some adaptation to cooling and heat dissipation when you go to the stratosphere, as you all know. This was a big deal for us in 2022. Our first images from stratosphere. It was no adaptation on the field of view, so it was quite coarse resolution. It was 5 meters, and it was in the visible range, as I said. But nice and crisp images. We showed that we could give very sharp PSF at this altitude. Last year we flew again in the stratosphere on the Sky high altitude stratospheric platform. It's a cool platform where you can fly very slow, and meaning you can get very, very nice SNR levels for a decent pixel size. And we're flying again with Sky in June for methane emission, special custom designs of our shortwave infrared cameras. And when I say shortwave infrared cameras, I mean up to 2.5, so extended sphere, which is called these days. Then I will say a little bit about what we do in space. Our biggest activity is a project called HyperNor. It's a ESA in-orbit demonstrator project where we are designing a shortwave infrared camera with good GSD for this size. You can see a CAD model on the right side here. I'll come back to this project. Over the last 5 years, we had support funding from the Norwegian Space Agency, and this year is no different. We have 2 projects today, or this year on this. It's methane detection and high specs on the moon. We are also starting a new activity very, very soon with some of the participants here in this meeting as well. It's a EDA-funded project called HyperIP, where it's kind of a hyperspectral camera for space for defense applications. And last year, we signed our first commercial space contract with launch already next year. So we're delivering an engineering model in 10 months and a flight model in 14 months for that project. We also have other commercial activities that I cannot say now. Yeah, HyperNor, the main kind of what's called goals there is to develop a low cost, low weight, low volume hyperspectral imaging system with a competitive performance. So of course not easy, but we believe that we have some specs that is fitting those criteria. Our goal was to produce something that is less than 20 kilos. We are ending up with something around 6 to 7 kilos, which we are happy with. And also our goal here is to have a low risk solution, meaning that there's a lot of new optical components that haven't been tried before. This is just a 3D printed version of HyperNor on the right side, but yeah, we are currently in the phase where we are getting offers from optical suppliers on the optics here. Yeah, it's a novel design with a dual slit solution, 9-meter GSD from 500K orbit. With a dual slit, we can use super resolution to get 4.5 meter, so 1280 pixels. Only 36 spectral channels. I would like that to be more, but this is the compromises you do, right? It's from 950 to 2500, and I think with a very impressive spatial and spectral misregistration, only 1% of a pixel and 1% of a band. MTF as Nyquist is larger than 0.21, and here you can see the SNR values for 100% and 20% target. The size is here, the weight is here. We hope to launch this in 2027. That's pending from ESA activities. We also have some customized off-the-shelf components that we are launching in shorter time frame than 2027. Yeah, we have are customizing a 3640 with a field of view reducer and a kind of telescope for methane detection, and we are also doing some other adaptation to that systems. We have a customized 3640 with a space grade detector. There we are on InGas, only up to 1.7 with launch next year. And we have a customized veneer solution, 400 to 1000 nanometer. And I'll do some customization also to put high specs on the moon. Yeah, and just in the end, I like this slide a lot from kind of a quote from Joseph Boardman, which I guess many of you have heard of, the four hurdles of imaging spectroscopy. So that's when you're making a hyperspectral solution, you need all your pixel to be uniform out of the box, or after the processing steps. You need it to be stable with pressure and temperature. Of course, the temperature is most important here. And of course, you need a traceable calibration so they can use the data for some scientific usage. And in the end, you are dependent on having, of course, a decent signal-to-noise ratio in each band. If you can't do this, there's no point, I think, in launching something to space. Thank you.